as you looked at the different graphs for problem number 10 yesterday, there were some important parts that I wanted you to recognize on there. One thing that I wanted you to find were the intercepts, the x-intercepts and the y-intercepts. So a reminder on those two things. First of all, x-intercepts, remember that's, if you can identify it from the graph, it's where it crosses the x-axis. But sometimes that's easier to find than others. Essentially what I'm going to look for is, with the x-intercept, when is y equal to 0? So you can do a couple different things on this one. This one actually, it turned out pretty nice because you could tell from the graph where it hit the x-axis. But maybe you even could have set the equation equal to 0 and then try to figure out, okay, well, what value of x is going to end up giving me 0 in that equation. But you can notice again that the x value was 5, or the x-intercept was at 5, 0. So that would be an important point we need to identify. The y-intercept. Well, the y-intercept, remember, that's when x is equal to 0. So one option here would have been plug it in, figure out what y is. In this case, we'd end up with 2 times 3, because the square root of 9 would be 3. And so you get a y-intercept where it was 2, or the point 0.02. Okay, so that's one thing that I wanted you to start remembering was x-intercepts, y-intercepts, how to find those. The other thing was it talked about the smallest x values, largest x values, smallest y values, and the largest y values. So let's look at this graph and see if we can identify those things. First of all, smallest x values. Well, this graph here, notice, started at this point, but then it continued on, and this arrow tells me it's going to keep continuing on. So really, this graph is going to keep going to the left, or really heads toward negative infinity. Now, negative infinity is not really a value, so I don't have a smallest value, but I do know it heads toward negative infinity. As far as the largest value for x, well, the largest value for x is what this point is right here. So you had to identify, well, what value was that we had over here? Well, as you started looking at these graphs, one option was to look in your table on your calculator. And if you looked in the table, you started getting values that had some errors. And that's why my graph stops at a certain point, because at a certain point, I get errors where I don't have values. Well, that certain point is when I had a square root that we tried to take the square root of a negative answer. So before I get to negatives, I get to 0. So in other words, I want to know, well, what value would give me 0 underneath that square root? Well, that value would be 9. So when x equals 9, which is what this value is right here, I get the square root of 0. And the square root of 0 is something I can do. However, if I go beyond that, I get, for instance, if I plug 10 in there, I get 9 minus 10, and that's a negative number. I can't do the square root of a negative number. So that's why my graph stops at 9. Anything above that gives me a negative value. So in this case, our smallest x didn't really exist, but it heads toward negative infinity. My largest x was 9. Whenever we look at the possible x values for a graph or for a function, what I'm really referring to is the domain. So the domain would be our possible x values. So for this example here, my possible x values, really we're going from the smallest number I could ever come up with, negative infinity. It, again, is not a specific value, but it heads toward negative infinity, all the way through positive 9. So how I'm going to write that is, in this case, I'm going to say that x has to be less than or equal to positive 9. Now, I included 9 because that was one of my points. Then they ask you about your y's. They wanted to know what's the smallest y and the largest y. So let's go back to my graph. Well, now I'm thinking from bottom to top because I'm thinking about the y values. Well, I know it started at that point when x was equal to 9. But I need to figure out, well, what was the y value there? Well, if I were to plug 9 into my equation, I'd have 9 minus 9 or 0. The square root of that is still 0. 2 times 0 is 0. And 0 minus 4 is negative 4. So that means this y value was negative 4. And that was the smallest y that I had. The largest y, well, that arrow again tells me it keeps going. So it really heads toward a positive infinity. So my smallest y was at negative 4. My largest y headed toward positive infinity. Well, when I'm looking at possible y values, I'm now talking about the range of the function. Well, our range here went from negative 4 up to positive infinity. So I might say that my y values have to be greater than or equal to negative 4. And that's something we're going to start looking at, our domain and range values as we look at different functions. So I picked out a couple other graphs, and I'm going to see if we can write the domain and the range. So let's start with domain on this graph here. Well, the domain, again, I'm going to think in terms of the x values. So on this graph, it actually started at a specific point, and it ended at a specific point. So it went from negative 10 to positive 10. So how I'm going to write that when I have a definite starting point and a definite ending point? I'm going to start with the smallest point that I had, and that was negative 10. All my x values were larger than that. Now notice I put equal to with it because we had a solid dot there. Up to a positive 10, which was our highest value. So I'd say the domain is negative 10 is less than or equal to x, which is less than or equal to 10. The range. Well, the range now we're thinking in terms of y values. Well, if I think about the y values, I'm going now up and down. So the lowest y value I got was at this point right here, or this point right here when y was equal to 0. The highest y value I got was up here when it hit the y-axis at positive 10. So I'm going to say the range goes from 0, that was less than or equal to y, which was less than or equal to positive 10. And so if you start with the smallest and go to the largest, I'm always going to have inequalities that look like this. Domain is thinking left to right, because those are the x values. Range is thinking bottom to top, because those are y values. All right, one last one here. This graph, again, starts at a specific point, and then it goes on forever after that. So if I'm thinking about the domain, the smallest value there would be whatever value I had for x at this point, which looks like it's whatever point gave me 0 underneath the square root. Well, if I plug in negative 4, that gives me 0. So it looks like I'm going from negative 4, which was less than or equal to x. Then it went on forever, so I don't really have a high point. So I'm going to leave it like that. Negative 4 is less than or equal to x, or you can say x is greater than or equal to negative 4. The range, that's whatever the y value is for this one. If I plug in negative 4 to that equation, I'd have 3 times 0 or 0, which means the y value was negative 6. So that was my lowest value for range. So my y values were greater than or equal to that -6. So we'll practice a lot of domain and range. Sometimes you have a definite starting and ending point. Other times we start someplace and maybe go off into infinity, either negative or positive infinity. All right, here's what I'd like you guys to try. I've got two different functions up here. I've got f of x is equal to 2x squared minus 5x plus 6. And I've got g of x that's equal to negative 2x squared minus x plus 30. Or if it makes it easier for you, think about both of these being y equals and y equals. Here's what I'd like you to try to do. I'd like you to try to come up with two different ways to determine the points of intersection. Okay? Again, I want you to come up with two ways that you could do that. I want you to go ahead and actually execute both of those ways. And if you've done it correctly, you should get the same answer in both cases. I'd like you to be prepared, though, tomorrow to explain exactly what it is that you did. So tomorrow I want you to try to figure out, okay, what are the two different ways that we can find those points of intersection? All right, so that's what I'd like you to spend some time on right now, seeing if you can figure out two different ways. Tomorrow, then, we'll talk about what those two different ways were and how we could actually attack those things.